or earpiece, two of you. Because I'm sitting so that your voice don't mess me up.
Hmm?
Yes, welcome. Can you hear me very well?
Yes, sir. Good evening, sir.
Okay, so let's go. Today we're going to be looking at chemistry. We're going to move a little bit faster since we believe in your strength to understand and move along with us. So today we're going to be looking at chemistry. And chemistry is the branch of science which deals with the study of the nature, composition, and property of matter, and the changes matter will undergo under different conditions. So in chemistry, you study what matter is made up of. Can you give me examples of matter like the drug you take, the iron, the plate you have in your house, the everything you have around you is matter. Anything that you can feel, something that has weight, has anything that can matter. So like this object I'm holding, this is a matter. So it has weight, it can occupy space. So what is this made up of? Is this steel? What kind of bonding is holding it? So when you study things like to study it and study its composition, then you're talking about chemistry. So how do you observe chemistry in your everyday life? You talk about rusting of iron nails. A new iron, you see that it is very shiny in color, but after some time, due to interaction with other substances around it, it gets rusted. So how do iron nails, how do they rust? You can explain that using chemistry. The palm wine that people take, how does the palm wine get to sour? A freshly cut palm wine is normally very sweet when you drink them, but after some time it gets sour. So that is chemistry. And burning, when you put a lighter onto anything that's any form of chemical energy, it burns. So how does burning take place? So all this can be explained using chemistry. And that is why we're going to be spending time in chemistry. So very importantly, we are going to go to the next thing, which will be test for purity. How do you know that something is pure? How do you know that something is pure? So there are three major ways you can check for something, purity of a substance. Talk about the boiling point, the melting point, and color. So those are ways you can determine whether a substance is pure. So if a substance boils at the right boiling point, then it is pure. If it melts at the right melting point, it is pure. So for colored substances, it has to show on the chromatography, it has to show at the right spot, one spot, and it shows that that is also very pure. So very importantly, I need you to understand what chemistry is, what, how, and where can we see chemistry around us, and the test for purity. So, Chika, can you tell me what chemistry is? Did you understand what chemistry is and what we are supposed to learn when we're talking about chemistry? You understand that?
Yes, I do.
Okay, so we're going to move pretty fast. So, test for purity. When a substance has been obtained from a mixture, it is very necessary to know whether the substance is pure or not. So, purity can be determined using melting point or boiling point of the substance. So if there is impurities, then the substance will not melt at the right melting point. So that is very, very important. Then a pure dye gives one spot on the chromatograph, melting point and a very sharp boiling point. It is a pure substance. So if something is supposed to boil at 100 degrees like water, but it boils at 110 or more than the boiling point or less than, that means that that is not pure. So you're going to see questions in this, in the objective question, asking you, how do you determine whether a substance is pure? So what parameters can you use in determining whether your substance is pure? So can you give three of such?
You can use a thermometer.
Okay. Yeah, you can use thermometer to measure temperature, very important. But the parameters that you can use in checking for the purity of substances, can you give me three parameters that can be used in checking for purity of substances?
So
Can you give me
I'm
that?
not sure if I know them.
Okay. You can use melting point, you can use boiling point, and you can also
Oh,
use,
that.
yeah. So you get it now, huh?
Yes, yes.
So, okay, so let's move on to elements, mixtures, and compound. An element is a substance which cannot be split up into simpler substances by any chemical means. And there are about 106 known elements scattered in different percentages all over the world. Water contains higher percentage of oxygen and nitrogen. So we have about 106 elements. Are you clear on that? Are you clear on the number of elements that we'll have?
Yes.
We're going to be moving pretty fast because I want us to get to separation technique that we can look at past questions as well. Okay, compounds. What are compounds? We looked at elements. We said that elements are substances that cannot be split up into simpler substances by any known chemical means. Can be split up into other components. Like the air that we know is a mixture of gases. So these gases can be separated into oxygen and lots of other elements. But once you say this is an element, it cannot be broken down into other elements. Just one pure element. And after looking at elements, it's important we look at compounds. So when you have these elements that cannot be broken up into simpler parts, when they are joined together using in any chemical form, we have what we call compound. So we say that a compound is a substance containing two or more different elements which are chemically joined together. Most substances occurring in nature are compounds, and their components are marble. So the marble that you use for your tiles and other things, they are calcium, carbon, and oxygen. The caustic soda is made up of sodium, oxygen, and hydrogen. The caustic potash is made up of potassium, oxygen, and hydrogen. Sand that you see all over the place, silicon and oxygen. Glucose is made up of carbon, hydrogen, and oxygen. Ethanoic acid that you get from your alcohol is made up of hydrogen and oxygen. You're going to be looking at them more in organic compounds. Then calcium chloride is made up of calcium and chlorine. Bleaching powder is made up of calcium, oxygen, and chlorine. Then you have the tetraoxosulfate 6 acid, very, very important acid. This acid, you use it in many chemical processes, made up of hydrogen, sulfur, and oxygen. Okay, so can you differentiate between elements, compounds, and mixtures? So I said that an element is a substance that cannot be split into smaller substances. So good example of element, you can talk about sodium, calcium, hydrogen, chlorine, all those are elements. They cannot be split into other elements. Then when you have one or two of these elements brought together, when you have two or more of these elements brought together using any chemical means, by them sharing chemical bond, you have what we call compound. Now, these compounds are chemically joined together. But when you talk about mixture are substances that are joined together physically. That means you can separate them. And this will lead us into separation techniques, where we'll be learning about how to separate mixtures. So when you're using separating techniques, you're not actually separating elements of a compound. We're separating the components of a mixture because a mixture is physically joined together, unlike a compound that is chemical. What are mixtures? A mixture is formed when two or more substances are physically joined together. Very, very important. You need to understand in mixture, talk about physical joining, whereas in compound, we talk about chemical joining. So they are not chemically joined in mixture. The environment we live in is composed of mixture. For example, the air is a mixture of different gases, like I said before. The air is a mixture of nitrogen, oxygen, carbon dioxide, water vapor, inert gases, etc. So for instance, the air is a mixture of gases. The earth is a mixture of soil, rocks, minerals, living organisms, plants, and animals. The sea is a mixture of water, salts, dissolved gases. So the components of a mixture may be elements or compounds. So these are examples of mixtures, like the seawater that contains water, mineral salts, dissolved air, bacteria. The air you breathe in is composed of nitrogen, oxygen, carbon dioxide, water vapor, inert gases. Petroleum, the major exports for our country, Nigeria, is consisting of petroleum gas, petroleum ether, petrol, kerosene, diesel. Palm wine consists of water, sugar, yeast, protein, fats, vitamins, mineral salts. Milk consists of water, sugar, fats, protein, mineral salts, vitamins. Urine consists of urea, water, mineral salts. Bronze consists of copper and zinc. Brass consists of copper and zinc. So these are famous mixtures that can be separated using separating techniques. Whereas these are the compounds which you don't use separating techniques to separate. If you want to work on the compound, you're going to be using a chemical process. You're going to be conducting reactions. Okay, whereas elements are those substances that cannot be split into simpler substances. So if you mix elements together, if you bring elements together chemically, then you have a compound. But if you get elements together or other compounds together physically, then you get what we call mixture. So you have to understand this. You have to understand the difference between an element, a compound, or mixture. Okay. So is the explanation, is it clear, or do I need to still get to it? These are just basics.
No, sir, it's clear.
Chika, are you there? Did you understand the basic explanation?
Yes, I understood it.
It's clear, and I want you to, yeah, I'm going to ask you as an assignment to give me the examples of an element, and you should be able to know about oxygen, nitrogen, carbon, sodium, potassium. All are examples of elements. I'm also going to ask you to give me examples of mixtures, compounds. You should be able to tell me about the sand that is made up of silicon and oxygen, glucose. Take glucose. People take glucose for energy. Ethanoic acid is made up of carbon, hydrogen, oxygen. So these are major. You have the bleaching powder that contains calcium, oxygen, and chlorine. Now you talk about mixtures. Most things that you see around you are mixtures. Then you talk about the air that you breathe in, consisting of nitrogen, oxygen, carbon dioxide, water vapor, inert gases. The milk, the urea, and bronze and brass, all these are mixtures. And mixtures can always be separated using separating techniques, okay? Chemical and physical changes. Matter can actually undergo either chemical change or a physical change. So chemical change is mostly permanent and they cannot be easily reversed, unlike physical changes that are temporary and can easily be reversed. So you should know that matter can always undergo either chemical or physical change. So we'll be looking at those in details so that if you are going to be applying some chemical or physical operations, some matters, you can have what we call separation. So with time, you're going to understand that better. Now, there are basic separation processes that we're going to be looking at. Evaporation, fractional distillation, the normal distillation, sublimation, filtration. So these are separation processes. We're also going to be looking at crystallization. We're going to be looking at chromatography and fractional distillation. And you should be able to understand how this works. Because in your exam, you're going to be asked, which process can we use in separating a mixture of so-so and so-so? What process can you use in separating a mixture of so-so? And so you need to understand what these processes are and how they can be used in separation. So do we continue?
Yes, sir.
Okay, so let's look at the separation processes that you have. Now, in your house, if you want to separate, if you have rice, actually using foreign rice, most foreign rice, they don't have sandstone in foreign rice. But let's say you're having your rice or beans and you have stone in them. Which process can you use in separating the rice, the stone from the rice, so that you can just have your rice, so that when you cook it and you're eating it, you don't have to break your teeth while trying to chew the rice? How can you separate the stone from the rice? Tika, can you help us with that?
Through distillation.
No.
You can use filtration.
Rice is a solid. Then you have
Okay.
stone. You can use what?
Filtration.
Ibuke, can you help us? Can you help us? We want to separate out the sand from
solids here. Maybe hand picking.
from your
Okay,
rice.
maybe hand picking. There are two solids here.
Huh?
I can't hear you.
Good. Yeah, that's how you can separate hand picking. Okay, but you can hear me. He
Yes,
said hand picking. Hand picking,
okay.
very important. That is how you can separate. If you have your tray and you have your rice of stone, the color of the rice is normally white. The rice is whitish, whereas the stones, they could be black in color or brown. So looking at them, you can see the color difference of the two, and you can see their sizes. So the rice, whereas the stone is brownish. So you can actually see the two and pick with hand. So that is, hand picking is just the most basic form of separation, provided you can see what you want to separate. Once you can see them easily, and once they can be differentiated by their color or their size, then you can use hand picking. So hand picking is very, very important, and that is a basic separation. So what's the essence of separating your rice from the stone? Because you don't want the stone to disturb the rice, so that when you cook the rice, you can have maximum satisfaction, and you wouldn't want something to be disturbing you while you're chewing. So hand picking is one way of separating. Now we'll talk about evaporation. Evaporation is a method of obtaining a soluble solid from each solvent. So when you're talking about solid, you can feel solid. They are more compact than liquid. Liquid is a fluid, whereas gases are also fluid, but very well separated. So when you talk about solid, you talk about things like your rice, you talk about sugar, all those are solids. But what's the difference between your rice and sugar? The difference between rice and sugar is that sugar can dissolve in water, whereas the rice cannot dissolve. Or what's the difference between your salt and your rice? If you put your rice in water, you still be seeing your rice separated from the water. But if you put salt in water, the salt will dissolve. So any solid that can dissolve in water is known as a soluble solid. Once a solid can dissolve in water, it is a soluble solid. But once it cannot dissolve in water, it is insoluble. So all those solids that are soluble in water, if you want to separate them from the solvent, which is the water, then you use what we call evaporation. So very importantly, you need to know that evaporation can only happen when the solid is soluble and it dissolved in a solvent. So solvent is normally the fluid or the liquid into which the solid is dissolved. So very, very good examples of this can be your salt dissolving in water. So the salt is a soluble solid, whereas the solvent is water. So a mixture of salt and water can be separated using evaporation. So how do you see this in your exam? Jamb or Waec, they are going to ask you, which of the following methods can be used to separate a mixture and water? And in the options, they are going to give you evaporation, fractional distillation, sublimation, and filtration. So you should be able to know that the answer to pick out is evaporation. Are we clear on this? Can I move forward? I actually wanted us to move faster so that we can check our past questions.
Yes.
Okay. So let me move forward. So number 2 is what we call fractional distillation, which involves separation of two miscible liquids with close boiling points. So when what you're looking at separating are two miscible liquids that can mix together, but they have varying boiling points. And the best way to go about it is by using fractional distillation. I'm going to show you pictures of all this so that you also understand better. But I want you to take note of what determines the separation process that you're using. So if what you're separating are soluble solids from solvents, you use evaporation. If you're separating two or more miscible liquids of close boiling point, then what you're going to use is fractional distillation. So a very good example of a mixture that can be separated using fractional distillation is a mixture of crude oil that contains paraffin, petrol, diesel, cooking gas. So when you go to our big refineries like the NNPC, what they use there in separating the crude oil so that we can have our PMS, you can have the cooking diesel and the rest. They use what we call fractional distillation. That is what is being used there because they're actually trying to separate two or more miscible liquids having close boiling point. Okay, let's look at the next separating process, the distillation. Distillation is used to obtain a solvent from a solution. So when you're trying to get a solvent, like I said, the solvent is the fluid that dissolves the soluble solid. So if you want to get that solvent, then you're going to be using distillation. So when salt solution is evaporated to the dry, you have just the dry solid. So that is an example of distillation. You want to take out the solvent. So the water vapor, instead of escaping into the atmosphere, you can do what? Collect it in a second cylinder, allow it to cool off. That's what distillation is all about. And let's look at sublimation, which is a method that can be used to separate a mixture which contains substances that can sublime. Very importantly, when you're talking about sublimation, the substances that are going to be separated, one of them must be able to sublime. So that is the condition. If it cannot sublime, then you cannot use sublimation. So this simply means that a solid substance can change from solid state to gaseous state. That's sublimation. Whenever a substance changes from the solid state straight to the gaseous state, we call it sublimation. The normal way that matter change state is from solid to liquid, then liquid to gas, or from gaseous state to liquid state, then to solid. But when it does not go through the liquid state, when it goes straight from solid to gaseous state, we call it sublimation. So one of the substances involved must be able to sublime, and that is the case where you can use sublimation for the separation. Okay, let's talk about filtration. Is the method of separating insoluble solid. So when you use evaporation, you're separating soluble solid. That means solid that can dissolve in water. But when you're using filtration, you're separating insoluble solids, solids that cannot dissolve. This is very important that you note the type of solid that you can actually separate with filtration. An example of insoluble solid is the sand. So if you mix sand and water, you cannot use evaporation because the sand filtration you can set up your filtration equipment so that once you pour in the combination of your sand and water, the filtering paper is going to hold the solid, whereas the water will go down. So with that, you're going to have your separation. So filtration is the method of separating an insoluble solid from a liquid by the use of filter paper. An example of an insoluble solid is sand mixed with water. So sand-water combination, you can use filtration to separate it. The kind of filter usually used in chemistry is made up of special paper known as filter paper with a filter funnel. So with that, you can have your separation. So you also have other techniques in separation like the crystallization, the chromatography, and the fractional crystallization. Okay, so let's look at those two again, those other three. So in crystallization, it is used to separate salts which decompose easily on heating their solution. So let's say you have a mixture that you could have used to separate or fractional distillation. You know that these two methods, they involve heating. You have to heat the substance so that the one with the lower boiling points can evaporate. So what if the mixture, when you heat it, can spoil the compound that you want to separate? What method do you use? The better method would be by using crystallization. So the salt crystals obtained in this way are pure and contain water of crystallization. Example is iron 2 tetraoxosulfate 6. And this other example. The salt is heated first to drive away some of the solvent, and then have such separation. So crystallization, you don't apply so much heat like you would have done in distillation. That's why it's a very important method. Then we'll talk about chromatography, which is a method we can use to separate a mixture by taking advantage of their different rates of movement in a solvent over an adsorbent material. Example, you have the chromatographic paper. So there are different types of chromatography. You have the paper chromatography or the column chromatography. For paper chromatography, the adsorbent material is filter paper, and a variety of solvents can be used, such as ethyl ethanoate or ethanol. This method can be used to separate dyes in black ink. So Jamb or Waec is going to ask you, which of the following method can be used to separate dyes in a black ink? So you're going to have option 1, crystallization, option 2, fractional distillation, option 3, filtration, option 4, chromatography. So what is supposed to be your answer? Supposed to be chromatography, because that is what you use in separating dyes. So whenever you're talking about mixture of colors, so you use what we call chromatography. And what is the underlying principle that a chromatography takes care of? The underlying principle that it works with is that it does this separation. Is a method we can use to separate a mixture by taking advantage of their different rates of movement in a solvent over an adsorbent. So we have two major types, like I said before, paper and column chromatography. Then lastly, we are going to be looking at fractional crystallization, which is used to separate two or more solid solids which are present in the same solution in roughly equal amount. The solubility of the different solids in the given solvent must be different. So solubility is actually what is utilized in separating fractional distillation. So I want you to take note of the various separating processes that we looked at. Evaporation, when you're separating soluble solid from solvent. Talk about fractional distillation, when you're separating miscible liquids with close boiling point, like in petrol. We talked about distillation, when you're separating solvents from solution. Remember, the first one is evaporation, soluble solid from solution, whereas distillation, solvents from solution. There's sublimation, when one of the components of the mixture can sublime. That's when you use sublimation. Filtration, when you're separating, and talk about crystallization for separating salts that are sensitive to heating. Chromatography, when you're separating colored substances like dyes. Then you talk about fractional crystallization, when you're separating two amounts in roughly equal amounts. Okay, so those are the major things. So what are we supposed to capture in today's class? The various separating techniques that you can use in separating mixtures. And we need to know the difference between elements, compounds, and mixtures, and also know the test for purity. The test for purity, like I said, there are three ways you can test whether a substance is pure: by taking the boiling point. If it's supposed to boil at 100 degrees, it has to be that 100 degrees. Very, very important. But if it's a solid and supposed to melt at say 45 degrees, it has to melt at that very 45. If it's not melting at its melting point, it's melting at 100 degrees or 30, then there is impurities. Impurity that can make a substance not to boil at the right boiling point or melt at the right melting point. So importantly, the three ways of checking whether a substance is pure are: by 1, checking the boiling point, checking the melting point, or using the chromatography to check if it is a colored material. Okay. So what are the difference between elements, compounds, and mixtures? Elements are there are substances that you cannot break down more into more other substances. Compounds, you are elements that are joined chemically together. Mixtures are substances that are joined physically together. And because mixtures are joined physically together, that's why you can separate them using the separating techniques that we've looked at. So that is a summary of what we've done. Very quickly, we've been able to cover like three things, three major concepts. The concepts of test for purity. I would say that we can test for substance purity by checking its boiling point. It has to be exact. Melting point has to be exact. And the spot that it met on chromatographic paper. Then we looked at the difference between elements, compounds, and mixtures. We said that elements are substances which cannot be split up into other substances by any chemical means. Very good examples of elements are oxygen, nitrogen, sodium, and the rest. Then compounds, on the other hand, are substances containing two or more different elements which are chemically joined together. So very important examples of compounds are the marble that you have. It's made up of calcium, carbon, and oxygen. Caustic soda is made up of sodium, oxygen, and hydrogen. Caustic potash is made up of potassium, oxygen, hydrogen. Sand, the normal sand that you see every time, is made up of silicon and oxygen. Glucose that you take for kids and people that are sick, it's made up of carbon, hydrogen, oxygen. Ethanoic acid, very, very important in alcohols. It's made up of carbon, hydrogen, and oxygen. Calcium chloride is made up of calcium chlorine. Bleaching powder is made up of calcium, oxygen, and chlorine. And tetraoxosulfate 6 acid, the very popular acid that we all know about, is made up of hydrogen, sulfur, and oxygen. Okay. Then mixtures are formed by physically joining substances together. Very important mixtures around us: the air, petroleum, palm wine, milk, urea, brass, making up of copper and tin. So take note of all these, and I don't know whether we have questions. Are there questions before we can? I want us to look at some past questions in both physics that we did yesterday and chemistry. We are going to look at past questions in physics and chemistry. I'm going to put them up, but I want us to be able to get the points, major points that we did today. Test for purity,
So
elements, compounds, and mixtures.
what about distillation?
Yeah, what
I
about
don't
what?
really understand it that much. The example on distillation.
Okay, distillation. In distillation, you actually separate. Let me get to the slide so that you can be looking at it while I'm. So in distillation, what you're looking at getting is your solvent. So your solvent is the main is the point that you're looking at. Unlike in evaporation, you just get you want to take out the solvent so that you get the soluble solid. Like if you have a mixture of water and salt, what you're actually looking for is the salt. So you can actually let the solvent, which is the water, to just evaporate up, leaving out the solid salt. So the solid is what you're looking for. But when what you're looking for is the liquid, the solvent, the water, then the best way will be by using distillation. So using distillation, you are also interested in that very liquid. So you don't just let the liquid to just evaporate and go. So you have a setup. The equipment is such goes up when it evaporates due to the boiling. There's a cooler part on the upper part of the distillation column that will enable you to collect that liquid. So the liquid is very important as against what we have in evaporation, where you're looking at the soluble solid. Okay. Any further questions?
So in evaporation,
Let's take questions.
is the liquid that is important in this solid is important, so I don't understand.
Yeah, in evaporation, the solid, you're looking at the device that you're going to be using. The equipment for evaporation is designed in such a way that the soluble solid is the most important thing that you want to get out. And in distillation, the liquid that is evaporating is also very important. So you're getting it out as well. So you're looking at the liquid mostly.
Okay, sir.
I'm going to show you that you. Okay, so class, everybody, I hope we got the concept that we're able to explain today. We moved from what chemistry is, which is the branch of science which deals with the study of nature, composition, and properties of matter, and the changes that this matter can undergo under different conditions. And we looked at chemistry in life, rusting of iron, palm wine, turning to some souring after some time. So please let me give you this time to quickly get down the notes so that we can have a very short break. Then we'll come back for past questions. Chika, can you go through the notes? They're very simple. Can you jot them down? Okay, so quickly do that.
I've written
So I can
down.
give. You've written.
Yes, it's only the separation.
Have you checked out? Okay, separation technique. That you don't need to write a complete note, just to take note of the major things. I hope I'm not covering your screen.
No, sir. No, sir. So it's covering my screen now.
Oh, sorry.
Thank you. So can you say an example of sublimation? An example of something that goes through sublimation.
Oh, yeah. When you look at solids like sulfur, when you look at things like camphor, do you know this camphor that they use in the house?
Yes, I do.
So camphor can move from, can supply, it can actually supply, can move straight from solid to the gaseous state without having to pass through the liquid state.
Okay. And then filtration.
You're getting now filtration now, right?
Yes.
Okay. Let's get to the next slide.
So I'm done with this part.
Okay. Can you get me?
Yes, sir. You can go to the
Can I
next
move to the
slide.
next slide?
So you can.
Okay. So I'm going to be signing off so that after 10 minutes, we are going to join back and we'll look at some past questions. So the past question we are going to be looking at, we'll be taking out some physics as well. We look at dimensions in physics and be able to solve out some problems. Then check out some measurements using vernier calipers that we did the last time. Okay.
Okay, they are still teaching. Okay, they are teaching now. Okay, they can do.
Samuel, these the scanning was according to the numbers. Huh?
Yes.
Okay, so I'm going to sign off now so that in 10 minutes time we'll look at actual problems from Waec and Jamb that relates to these separation techniques that we've looked at. Then we'll look at actual problems from Waec and Jamb that look at dimensions and measurement that we did in physics the last time. So please, you can get your notes down so that when we are solving, you'll be able to solve along with us. You can check out your textbooks, chemistry textbooks and physics textbooks, solve along so that we can actually make it part. So if I sign off now, just log in back using the link that I'm going to share. So in the next 30 minutes or or in the next 10 to 20 minutes, I should be able to log in back and to look at them. Also, always take down the notes. The notes I'm giving, they are just PowerPoint notes. They are strictly to the point according to your curriculum. I'm not going through everything. Like if I go to chemistry now, I'll look at adverse effects of chemistry, work you can get in chemistry. All those things are story, and they don't come out in your exam. So what I'm looking at is the actual PowerPoint, the things that come out in the exam, exactly the way they come out. So that's how we'll do it. Once we are done looking at the concepts, we'll go to the past question immediately. So that as you're going through and you're capturing all those areas in your past question, you're already getting prepared for your exam. So it's not a class that is supposed to be so detailed, looking at every other thing that will take your time. Some of you are going to be writing your exams you're going to be writing your exams in 3 months' time. So we're going to imbibe an approach that can actually help us to get to what we want in time, instead of wasting so much time on things that are not important. Are we together?
Yes, sir.
Okay. So please let's use this 20. Yeah, let's use these 20 minutes. Look at this concept that we define. Check out your textbook. Look at their diagrams and get used to them, so that in the past question that we're going to practice, you'll be able to see them, see the way they come out in the exam. And I will be explaining them one by one, so that when you see similar questions, you'll be able to understand. Okay, thank you, and see you in 10 to 15 minutes time. I'll share the link again, so that anywhere you're getting your link from, if it's on the WhatsApp, you'll be able to see and join us. Thank you.
Thank you, sir.